Okay, 8a of the review. If the following linear system of equations has the same slope and the same y-intercept, what must the value of k be in the second equation? So same slope, same y-intercept. That is same slope, same y-intercept. So same slope, same y-intercept. Infinitely many solutions. And I know if it's infinitely many solutions, that this is just a multiple of this equation. So we could do something like, what do I have to multiply this equation, this negative 4 by to get a positive 8? Well, I'd have to multiply by negative 2. So that would turn that equation into a positive 8x minus 6y equals a negative 4. If I rewrite the other equation underneath it, 8x minus ky equals a negative 4. I know infinitely many, I have to get a true statement. So this is negative 4, negative 4. These variables are going to have to go away because I'm going to be left with 0 and 0. So what does this value have to be? Well, it has to be the same as that value. So I want to make these equations the same. So k really has to be 6. So my k value is 6. The way we did it in class was I looked at these. Negative 4 over 8 equals a negative 1/2. I see 2 over negative 4 equals a negative 1/2. So if that ratio is the same, I know that 3 over negative k would have to equal a negative 1/2. Well, what number would this have to be? K would have to be 6 when I solve that. So either way we do that, k is 6. You don't have to do it both ways, either way. Alright, 8b, if the following system equation has no solution, so parallel lines, what must the value of k? So I know that for no solutions, I know that the variables are eliminated, and the result is, for no solution, is a false statement. False statement. So what does that mean? Well, once again, what do I have to multiply this equation by to eliminate this 3y? I'd multiply that top by 3. So if I multiply the top by 3, I'm going to get 3x minus 3y equals a negative 4. I'm going to rewrite this bottom equation. Negative kx plus 3y equals 2. So I know I have to eliminate these variables. So right now the y's would go away. This on this side would be a negative 2. I know I need to get this to go away, and I'd have 0 equals negative 2, which would be a false statement. So what does this value have to be? Well, k just has to be 3. Because I need a 0 over here. So really, if I want to set up algebraically, k 3 minus k equals 0. I would add k to both sides, and I get 3, k equals 3. So k equals 3 is the answer. 9a, a drummer is stocking up on drumsticks and brushes. Drumsticks cost $10.50 a pair, brushes $24 a pair. He spends $90 and buys a combination of 6 pairs of drumsticks and brushes. How many pairs? So let's define our variables. First, x equals y equals. We're going to say x equals, they're looking for the number of drumsticks. So number of drumsticks. Y is going to be number of brushes. So now we need to make two equations. Well, let's see. The cost equation, we could say $10.50 times the number of drumsticks, so times X, plus $24 times the number of brushes, so that's Y, is going to equal his total cost, which is $90. That's my cost equation. My quantity equation, he buys a total of 6. Well, that 6 is the number of brushes plus, or the number of drumsticks plus the number of brushes has to equal the total, which is 6. Okay, so I would use substitution. I would take this equation here, solve for Y by subtracting X. Subtracting X, I get Y equals a negative X plus 6. I'm going to take this Y and substitute it into here. So I'm going to rewrite that equation over here. I'm going to say $10.50 times X plus 24 times negative X plus 6 equals 90. Okay? 1050X plus 24 times a negative X is a negative 24X. 24 times 6 is going to be a positive 144, and that equals 90. So I get 10.5x minus 24x. That's going to give me a negative 13.5x. I'm going to subtract 144 over. I get that equals a negative 54. Divide by negative 13.5, and I get x equals 4. What's x? That's the number of drumsticks. So I have 4 drumsticks. How do I find my y? Well, I can plug it right back into here. So I can plug this right into there. I could say y equals a negative 4 plus 6, which is 2. So it looks like they bought 2 drumsticks or 4 drumsticks and 2 brushes, and 4 sticks, 2 brushes. Choice number 3. Okay. 9b, same thing. We have to define our x and our y variables. So let's read that question. A family of 15 spent a total of $172.50 on movie tickets to see The Amazing Spider-Man 2. Adult tickets cost $13.50 each, and child tickets cost $10.50 each. How many pairs of each tickets? So I'm going to say x is the number of adult tickets, y is the number of children tickets, or child tickets. So my money, adult tickets cost $13.50 times the number of adult tickets, so that's x, plus child tickets $10.50 times the number of child tickets, which is y, and that's going to equal my cost of $172.50. And they said a family of 15, a pretty big family. So x plus y, the number of adults plus the number of children, equal 15. I'm going to take this 15, I'm going to say y equals a negative x plus 15. I move that x over, I'm going to solve by substitution. I'm going to take this and substitute it into there. So I'm going to rewrite it over here. $13.50 times x plus 1050 times y, but y is going to be x minus, or negative x plus 15, all equals 172.50. Alright, we need to clean this up. 13.50x minus 1050x, 10.50 times 15 is 157. 50 equals 172.50. Trying to squeeze it all in here. We're going to combine this. This turns into a 3x equals, I'm going to subtract 157.50 over to the other side, and I get 15, so I get x equals 5. So adult tickets cost $5. Or, I'm sorry. The number of adult tickets is 5. So if the number of adult tickets is 5, well, I can plug it right back into here. So 5 plus y equals 15. Y is going to equal 10. 10 children, 5 adults. So where do we got that? Choice number 3. 5 adults, 10 children. Okay. Last two on this page. If a system equation has infinitely many solutions, what does the graph look like? Well, it's the same line. The graph just this line, and then we graph another line right on top of it. Infinitely many. If the system equation has one solution looks like there's a line and there's another line. Crosses, intersects at one time. One point, so intersecting lines. Oops. So there's the top.